Hello students, welcome to the second part of Aromaticity. Some 10 interesting hand-picked questions are going to be solved in this session. So I request you to be ready with a paper and pen, pause the video and solve the problems. Let us start. The first question goes like this. Which of the following compounds will give curdy precipitate with the silver nitrate solution? Okay students, the answer is option B. See, in this solution, in solution, silver ions will produce Ag plus ions. This will produce Ag plus ions, which will always look for Cl minus ions. When they combine together, they will give you curdy precipitate like AgCl. But in which among the compound I can successfully remove chlorine atom as chloride ion will be my answer. In option A, chlorine will be strongly bonded to the benzene nucleus. We know that there is a partial double bond character that exists between chlorine and carbon of benzene nucleus. So it is difficult to break. And in option C, chlorine is bonded to vinylic carbon. This is alpha and this is beta. And there is a pi electron cloud between alpha and beta, which will immediately join with the lone pair of electrons that are available on chlorine. So there will be a complete pi electron cloud that will cover this chlorine with the alpha and beta carbon, which will make us to remove chlorine atom from this compound. So that's why it is difficult to break here. The same reason is can be applied in the option D also. So option B is the right answer, because once I remove this chlorine as Cl minus, this species is going to attain aromaticity. That's why option B is the right answer. Now the second question. To convert given compound into aromatic compound, the best reagent is. Okay students, the answer is option A. See, if I successfully remove this chlorine as a Cl minus, then the remaining species, this carbon is going to get positive charge. The remaining part is going to become aromatic. The remaining part will become aromatic, which means I can I need to have a Lewis acid like AlCl3. That would be the best reagent to remove chlorine and thus generate a carbocation. Fine. Now let us see the third question. Which of the following compound will have lower pKa value in the lower pKa value? That's it. The answer is A. See, lowest pKa means highest acidity. Now in option A, there will be two hydrogen atoms. Two hydrogens will be present here, everywhere there will be two hydrogens. Now, if I remove these hydrogens, if I remove one of the hydrogen, if I remove this hydrogen, this carbon is going to become a carbanion. So is this carbon and this carbon, and if I remove this one, this will get negative charge. Now when I analyze for the stability of these species, in option A, the first compound would have attained aromaticity, and that's why the option A is the right answer. Let us go to the fourth question. Which of the following compound will have highest pKb value? The answer is option A. Highest pKb means lowest basicity. See, in option B and C and D, in these compounds, the lone pair of electrons on nitrogen is localized. Whereas the lone pair of electrons in option A is used to construct ring current and thus to attain aromaticity. So the lone pair of electrons on nitrogen will not be available on nitrogen in compound A. This lone pair of electron is responsible for the receiving of H plus ion protons. That's why option A is the right answer. Fifth question. Give the decreasing order of the stability of the following. Okay guys, the answer is option C. Option C. That's because we know that aromatic compound is more stable than non-aromatic than anti-aromatic. So this compound is aromatic, this compound is anti-aromatic, and this compound is this compound is non-aromatic and this compound is anti-aromatic. That's why the option C is the right answer. Now question number 6. Which of the following will dissolve in HClO4? Okay guys, the answer is option C. Compound 1 and compound 3 will dissolve in HCl4. Now this is an acid, which means it will release H plus ions. Now when H plus ion comes and attaches here, okay, hypothetically I am going to attach H plus ions. Immediately this bond will come there and it will become a single bond and positive charge will come to this carbon. Now this part will become aromatic. Apply the same concept here. Positive charge over here, and this will become anti-aromatic. Whereas here again plus charge will come here, and this part will become again aromatic. So compound 1 and 3 will be stabilized by aromaticity, and that's why they will dissolve in HClO4. Whereas compound 2 will attain anti-aromaticity, which is least in stability. That's why the compound will resist and it won't dissolve in HClO4. Let us see the next questions, students. Question number 7 goes like this. Which of the following compound will have highest dipole moment? Okay, the option is C. See, dipole moment means when the carbonyl carbon undergoes maximum polarization, then the dipole moment will be greatest. Now hypothetically I am going to consider that this bond has been polarized. So negative charge and positive charge. If it comes, this is just a secondary carbocation, that's it. But whereas if this bond shifts here, this will get negative and this will get positive. Now the resultant ring is aromatic in nature. Whereas here nothing will happen. That's why the compound 2 will have greatest high dipole moment. So that's why option C is the right answer. Question number 8. In which of the following compound the carbon oxygen single bond or bond length is the longest one? Okay students, the right answer is option D. It is compound 3. See, in compound we know that carbon oxygen single bond is longer than carbon oxygen double bond, and in compound 3 after polarization the ring will attain aromaticity. See, again I am going to hypothetically consider what will happen. Okay, so this will get positive, this will get negative, this will get negative, positive. Now this species is aromatic, whereas this is anti-aromatic, and this is non-aromatic. Again this is already non-aromatic. So that's why the compound 3 will have greater carbon oxygen bond length. So option D is the right answer. 9th question. Which among the following compound will react with ammonia faster? Okay students, the correct answer is option A. Boron is the electron deficient atom, hence it can be considered as a carbon atom that carrying positive charge, carbocation. See, so I can consider BH3 as similar as CH3 plus. Both are one and the same as far as as long as they are in the ring. Okay, so in option A, the vacant orbital on boron is being utilized. Is not being utilized, because if it is being utilized, then the compound will become anti-aromatic. Whereas option B, C and D, all these 3 compounds are aromatic. This is aromatic, this is also aromatic, and this is also aromatic. All are aromatic. This compound will become anti-aromatic. So that's why ammonia having lone pair of electrons can donate into boron's vacant orbital, and thus it forms adduct. So option A is the right answer. Question number 10. Which of the following compound will have greater aromatic character? Okay students, the right answer is option D. It is compound 3. Now after polarization of compound 1, it will become anti-aromatic. See here, if this bond polarizes, then this will get negative, this will get positive, the whole ring will become anti-aromatic. Whereas this compound will become aromatic, and so is this compound, negative and positive. Again this part will become aromatic, whereas here it is already non-aromatic, and it will remain as non-aromatic only. So compounds 2 and 3 after polarization will become aromatic. But the wonder is, in compound 3, the oxygen which carries negative charge can form intermolecular hydrogen bonding with the adjacent hydrogen atom which is present with the OH group. So that brings an effect called chelation. Okay, chelation. Chelation will bring in stability. Such chelation is not possible with the second compound, as the angle won't support for chelation. That's why option 3, that is compound 3, will have greater aromatic character. That's why the option D is the right answer. Thank you guys. Happy learning.